Welcome, everybody. Thanks for shutting the door. Thank you. Welcome to 5 design patterns for building resilient applications. So over the next, over the next 45 minutes, you'll be in one of 3 camps. Camp 1, you'll learn about some new patterns that you can implement in C# to build more resilient apps. Camp 2, you might find some reaffirmation of patterns that you already use to build resilient apps. Camp 3, you'll hold your head and go, oh, no. More on that later. My name's Derek Bingham. My pronouns are he, him. For those of you who don't know me, this is my first time I've ever spoken at an NDC conference. It's not my first rodeo in terms of speaking, but my first NDC, so I'm pretty excited to be here. A bit of background. I usually walk into a room and go, hi, I'm Derek, I'm a developer. I've been writing software for 20 years. Started off in Java, in the Java stack, moved to .NET about 10 years ago. And then for 8 of those last 10 years, I've been building cloud native applications. Starting off in Azure, spent about 4 years building stuff in Azure. Built a startup in Azure, that was fun. Didn't work, but that's startups. And then for the last 4 years, I then joined AWS, where I am now, and I work as a developer advocate. Plenty of room up the front. I really don't bite, really, honestly. So 4 years at AWS. Now you may detect a small accent. I'm originally from Ireland. I'm very proud from Belfast in Northern Ireland, and I've got green shoes, my green connies, just to point that out. I currently live and have lived for a very long time in Perth, Western Australia. And hence I've got a great suntan. I've got the Irish suntan. So that's me, and that's my side-eye look. I like the side-eye look. So I'm going to start with a quote. I like starting with quotes. So this one is, failures are a given, and everything will eventually fail over time. This particular quote comes from the CTO of Amazon. And when I first started giving talks on resilience, people would shake their heads and go, failures, bad. No, failures are good. Failures are to be embraced. Because like anything, if you build, nobody's ever going to build the perfect application. And specifically now, when our applications are distributed across different stacks, different networks, there's a lot that can go wrong. But that's fine. What we have to do, and the challenge that we have as software engineers and software developers, is to make sure that when they do go wrong, that we cater for them. So today, I'm going to show you how. By going through 5 patterns and 1 practice to help you build those modern apps in a more resilient manner. So I'm going to start off with what is like the baseline of all patterns is timeouts. So hopefully, who has never used a timeout? Thank you, Ian. I know you have. Who has anybody not heard of any of those patterns? So you've all heard of those patterns. Excellent. That's a really great start. And who is currently doing chaos engineering? Awesome. So we'll get into chaos engineering at the end. Chaos engineering is something that when you're building resilient applications, it really goes hand in hand with these patterns. So today I'm going to build an application. Like all good talks, we'll take you on a journey. We'll take you on a journey of this application and how I improve it over time by implementing these patterns. Warning, there are bad jokes ahead. Really, really bad jokes, hence the group 3. Oh. So be prepared. I don't intend to offend anybody in any way, but they're really bad. So warning, just be prepared. So here we are, we've got the application. I'll give people time to read jokes. So what do computers eat for a snack? Microchips. You'll have a punchline, a setup, a punchline, and a source, and a button. And if you hit tell me another, it'll go, once it's tell me another, it'll hit an API, and it'll get you another random joke. Only 2 hard things in computer science: cache and validation, naming things, and off by 1 errors. Hey, yes. So every joke, this is the back-end service for that front end. And it has, this is the JSON that it's dealing with. And this is the actual class and project that it is. So I've got a little React app here. So the React app itself, very simple. It's got an app.js, and it's got a fetch joke component. Inside the fetch joke component, again, very, very simple. It's got a bit of a UI, which I won't really show you. It's very simple. And the main function inside this is populate joke data. Again, very simple async function. It sends a request out to an API, and it gets back a joke in JSON, deserializes it, and sticks it in the UI. So that's the front end. So what about this API/joke? So this is a .NET controller, and the .NET controller returns a list of jokes. It implements the iJoke client, and I've got one implementation of the iJoke client interface. It is here. So what it does, it grabs the HTTP client, it sends a request out to a passed-in third-party joke API, and then gets the result, serialized, deserialized, returned to the .NET controller that I just shown, which then pushes it on to the client and displays the marvelous jokes. The joke object itself is a setup, punchline, and source, and it's got accessors and mutators like any other object. And that is it. So the net benefit is, tell me another, .NET microservice, third-party joke API. Result, are monkeys great at sports? They are born champions. And that is the application. So so that was the code. Here's some architecture. So PowerPoint architecture, my favorite. So this is React web application, makes a request to the .NET microservice, which basically acts as a proxy. It's not doing anything special. So the proxy to the third-party joke API. So in this particular example, I'm using a third-party joke API. But in the real world, it might be a database service, it might be another microservice, it could be anything. It's just I'm identifying that what happens when these things go wrong. So the third-party joke API returns a response, which then proxied back through our friend the .NET microservice back to the React web application. But we all know that failures happen. So what happens if the third-party joke API fails? What happens if it doesn't return? Well, the React web application has no idea, so it'll keep processing requests, proxy through the .NET microservice, which has no idea that this third-party joke API is broken. And it'll wait. So it'll wait for an indeterminate amount of time, depending on the language that you're using. So in C#, default timeout for HTTP client is 1,000 millis, 10,000 millis. 10,000 millis, which, is that enough for your users who are waiting at the same time? Probably not. They probably want a faster response. But that then that cascades back to the users, and they'll see the spinning wheel. However, what happens if we have multiple clients? What happens if that multiple clients start making requests for jokes? Because let's face it, everybody wants a new joke. That goes to the .NET microservice, which then, again, pushes it through the third-party joke API, which is not working. It's broken. It's failing. It's not returning responses. So that request will, in fact, wait as well. So what does that do? Well, those cascading errors then will put the .NET microservice under load. So what you'll actually start getting is cascading failures. And then the React web application, well, they still don't know that everything is broken, and they will still start requesting everything. So your users are going to be so unfulfilled because they don't have any jokes for the day. I know, it's bad. It's bad. So let's fix it. So the first pattern to fix these sort of errors is called timeouts, and we use this as the baseline. So here we are back in the implementation of the joke client. So luckily, the HTTP client itself has a property called timeout. So instead of using the default time for HTTP client timeout, we can override that and set a time span for 5 seconds. That way, we are making the request time determinate. So we are saying, well, I'm only waiting 5 seconds. So what effect is that going to have? So I'm refreshing the client, and we get a spinning wheel. And sometimes we'll get a joke. But if we refresh again and keep refreshing, eventually our .NET service is going to fail. So we'll keep going and trying to get jokes, and then all of a sudden we get this spinny wheel. So what's happening? Well, if we go back into our .NET microservice and do the same action, so we're requesting a joke, sometimes it'll start responding, and other times we'll get an unhandled exception. It's a timeout. The timeout has said 5 seconds has went, boom, I'm done. But we haven't handled that exception inside our controller. So that is, if you're doing nothing, is something you should do, is a timeout, because what you're doing is constraining that try. And constraints are good. But there's more, much, much more. So who here has used Poly? Who here has used Poly thinks Poly's flipping awesome? Yes, it is. Poly is a resiliency library for C# that is, let's face it, right? Developers, we're lazy. We're not going to rebuild the wheel. We're not going to reinvent the wheel. If there's a library that does it for us, yes, please, thank you very much. So Poly is the .NET library. There's libraries for Java. There's libraries for TypeScript as well. That will do the same thing, i.e., write the code that we don't have to, so we can build the resilient applications. So for the rest of the demo, I'm going to use Poly. For those of you who haven't used Poly, check it out. So the next part is I'm actually going to remove the default timeout. So instead of using the default HTTP client timeout, I'm going to use Poly. So Poly, you define Poly as a policy. So everything in Poly is a policy, hence the name. So I can write a timeout in Poly by calling the timeout async method, giving it a value. Again, I'm doing 5 seconds. Just to prove it is Poly, there it is. Once I've defined that, the other thing you have to do in Poly is actually execute the policy. So I'm now doing the execute async, and then async anonymous function inside it, which I'm going to define a cancellation token. Now, what code do I have to put inside this function? Well, obviously, the client code that calls out to my third-party joke API. Fix the indent, and who needs spaces? And then next thing, I define this cancellation token. So CT is the cancellation token that I'm defining, and I use it because I can then add it as an argument to all the asynchronous calls inside this function. So there's two. There's the HTTP client get, and then there's the read as string async. This gives me better granularity into the timeout. So this makes this better than the original timeout. And if I run the application, you'll see that although we get similar behavior, so we'll refresh the client, and sometimes it'll work, and sometimes it may not, because the third-party joke API is going to fail. But when it doesn't, we have better control over those asynchronous tasks inside the HTTP client calls. In this case, it failed because it had a task cancelled exception. Now, just to reiterate, they're the two CTs, or cancellation tokens, that can be invoked, and that will give you a better control over your calls. Now, what I didn't mention is the third-party joke API itself is completely random. So the failures will happen for an indeterminate amount of time over a completely random time. So sometimes they'll work, and sometimes it won't. And that's what we're trying to prove. So we've had our timeouts, we've implemented timeouts. The next one we need to implement is graceful degradation. So currently, our timeouts, we've defined a timeout value. We have better control over asynchronous calls, but we've got great big exceptions in the controller, which is, we need to handle those. We need to degrade gracefully. Hence, the name of pattern 2, graceful degradation. So here, we're going to define what's called a fallback. So a fallback is something that will be returned to the client if the third-party joke API is not working or is failing. So how would we implement graceful degradation using Poly? So to define graceful degradation, we first must define a fallback. So we define a fallback again using Poly. So we define a policy, and the policy itself needs to return what the API is going to return, i.e. a list of jokes. And when must this fallback be invoked? Well, I'm going to handle exceptions. You don't have to be as verbose as this. You can be quite directed, but exception is good for this demo. And then when that exception is handled, what do you want to do? What is the fallback going to do? Well, it's going to return a list of jokes, and it's going to do that in an async method. So I define, again, an async method with the cancellation token, and it's going to return a list of jokes. Now, for this demo, I'm just going to do a single joke, because you really don't want any more. But usually for fallbacks, you define a list of potentials and then choose a random one. So with a joke, you need a source, a setup, and a punchline, setup, and a source. So I'll define the setup and the punchline in a bit. The source is something different. So I want to indicate to you and to my users where this joke has come from. So I define the source as fallback. Once I've defined this function, I then need to tie it into my policy, so my Poly policy. So remember, the exception that invokes this fallback comes from the timeout. So I need to wrap the two, and I do this using a policy wrap async call, and inside this, I define the policy. So that's the one that's actually raising the initial exception. I then make the policy wrap the initial executor. And that's it. So the last thing to do is another amazing joke, which is I am in a band called 1023 megabytes. Anybody heard? We haven't had any gigs yet. Anybody? Anybody? Oh, groan. We've got a groan. Nice. So that's our joke, and let's execute F5 this and see how we go. Please ignore my errors. This is a demo. So they're just warnings. So let's refresh the client first of all. So what we're doing now, we're retrying. So all of a sudden, we are in fallback because we've hit the 5-second timeout, and it's invoked the fallback. But if you had tell me another, hopefully, there we go, we got a UTB joke, even though we might not. That came from the third-party joke API, which is recovered, which is fantastic. Our application is still running, even though the third-party API has went through failures. Again, from the controller, why don't we have verbals have time? Because they're not when wolves. So This is all coming from the third-party API, which is all recovered, and so our fallback is invoking, and it's giving the API time to recover. So that's it, our fallback, generate a fallback, wrap it the policy, saying after 5 seconds, raise an exception, the exception is handled, and then the fallback is returned, so our application can continue delighting its users, and hopefully they'll have lots of jokes to keep them going through the day. So that is gracefully degrading. Pattern 3 is retries. So retries is all about, when I mentioned graceful degradation, I mentioned giving the API time to recover. Retries is the next evolution of that. We want to say, okay, when I make a request to my third-party API or my backend service or microservice or anything, one request is not enough because maybe it needs time to recover, so let's try again. And that's what a retry is, trying again. So to implement a retry, I'm just going to refactor this general fallback into just its own method, just to clean it up a bit. And I'm taking all the defaults. So enter, and so the next thing I'm defining is my retry policy. So the retry policy itself, again, a poly policy. And what I'm doing here, I need to handle, again, when to retry. So again, I'm being quite verbose with this and going with exception. You don't necessarily have to, that's for sure. And I'm calling the retry async method within poly as a result, and giving it a retry count. So how many times am I going to retry on exception? Once I've defined that, I then need to put it in my wrapper. So the wrapper, think of the wrapper as an order of precedence. So what I'm doing is saying, well, first one, policy. So do an initial timeout, then retry policy, so retry 5 times. And then if both of those do not work, or raise an exception, then it's general fallback. So F5 that, and let's see how that works. So what I'm expecting is longer times with the spinning wheel of death, as I call it. So although you need to be careful about how much time you let your users wait, and that's something that you have to define. I'm just using 5 seconds and 5 retries as part of this demo, but just be very reticent and very aware of what your users are experiencing when you're defining your retry policy. So there we are. If we've retried 5 times and we've got our fallback. So again, the third-party API is not working, but then we tell me another. We got 10 types of people in the world, those who understand binary and those who don't. That's my particular favorite. And then if we go to the back end, we hit refresh, so it's retrying. And we've got our monkeys joke again. So the third-party API is good. We hit it again. Why did Bilbo Baggins always eat his lunch at noon? He was a creature of Hobbit. Come on. We retry again, and you'll notice that although it's maybe waiting a little bit longer, we're always getting results. So implementing the retry pattern. And then sometimes we go beyond our retry attempts, and we'll get our fallback. And there we go. So what's happening is our application is beginning to handle these failures better. We've got rid of the exceptions. We have been quite specific in our timeouts. And now we've added a retry of 5. And then finally, always going to our fallback. We always have that fallback to invoke, so our users always get something to look at, or a joke to look at, which is good. So that is retries. However, like everything, it is not the end. There's many challenges with the default retry, many challenges. The first challenge, well, the challenge I'm going to talk to and why we need this pattern called exponential backoffs is this. So a React application is calling through to our .NET microservice. And then we're retrying 5 times. So we first of all, we try, and then we wait 2 seconds and we try. And then we wait 2 seconds and we'll try. And what that's actually doing, because we remember our retries, we're trying to implement our retries to give our third-party API a chance to recover. But what we're actually doing is hammering it even more. So the third-party API, it's trying to come up again, and we're just retrying it again, and it's going, whoa. So it's not great. So exponential backoff is all about building on that idea or concept of letting that third-party API recover. Give it time. Give it time to do what it needs to do to get better. So instead of having our next retry after 2 seconds, we increase the retries exponentially. So we wait 4 seconds until the next one, and then 8 seconds until the next one, and then finally, after 16 seconds, hopefully, arbitrary numbers, of course, hopefully the third-party API has recovered and can send us another marvelous joke. So let's implement the exponential backoff. So it's basically a retry with a fancy timer. Shock. So what we need to do is get rid of the default retry code and add a wait and retry async. So here we're going how much duration between a single retry and how many retry attempts do we need to make. And then we do some maths. So we think a time span based on the number of attempts that we've done times the power of 2. So what that's doing is we'll build an exponential retry. And that's it. So simply by defining this wait and retry async, number of retries, pass in the retry attempt to a little math power, you can build your own exponential backoff. So let's see how that works. Again, what you'll see is as we retry, the time will go out. But we should always get that result, even if it's a fallback. So you'll see we're spinning, there we go. What do you call it, Dever from Finland? Nerdic, very apt, where we are today, thank you. And then we refresh again. Apologies to any Finnish in the audience, thank you. So this is taking some time, so obviously we're quite a long way down our retry attempts. And we're going, and we're going, and we're going, retrying. There we go, and we're back to our fallback. But when we retry again, we've got our great monkey joke back. So our third-party API has come back, and our retries have worked. So a refresher, very simple. Take your default retry policy and add a wait and retry async to it. Define the number of times you want to retry and the time span between those retries, which you can define and have using a math to the power of whatever. It's up to you. Again, always thinking about your users. How long do you want them to wait for in this case? Or how long are you willing to take that potential downstream effect of them waiting? But there's more. There's always more. Only 5 patterns today, but there's a lot more. So we've done retries. We have defined that retries, well, they're good, but they're not great because they don't give our API, a third-party API in this case, time to come up again. So we add an exponential backoff. But as I said, developers are lazy. Everybody does a power 2. So what happens? You get clustering. So you get clustering of your retries because somebody has went to a talk, seen some crazy Irishman at the front do a retry with an exponential backoff and went, oh, I just do more math power 2. Just do that. What happens, you do that in enough services, you get clustering. So that is again putting your services that you're calling under load because all the retries are coming at the same time. So it's not going to have a good day. So what we recommend and what you should be using when you do a retry and exponential backoff is add jitter. So jitter is a way of adding a random time to your retries. So that way, they'll flatten off those retry curves, and your service will have less retries to handle while it's trying to come up again. Let's implement it. So this is even easier to implement than the exponential backoff, because what we're doing is simply adding a time frame. And in C#, that's really easy. We've got time span, we go from millis, and then we define a random value of millis. So I'm just going to do new random between 0 and 1,000 millis, and that will allow me to have flatten that retry curve and add jitter into my exponential backoff. That's it. Nothing, easy peasy. So when you're doing retries, go, okay, I probably need to add an exponential backoff here, and then go the next step and add jitter. 3 lines of code. And your consuming services and the people who look after them will forever be your friend, within reason. Unless you tell them these jokes, then you're stuffed. Okay, pattern 5. So there's been some similarities between pattern 1 and pattern 4. Pattern 5 is a little bit different. The circuit breaker brings into thinking state. So with a circuit breaker, it has an awareness of the current state of the third-party API. So the idea being, if it knows that the third-party API is not behaving or failing, then it can jump in and service requests instead. How does that look in our old friend, the PowerPoint architecture diagram? Well, like this. So we have our application proxying through our .NET microservice to our third-party joke API, which is failing randomly. And we'll keep requesting, and it's still failing, so there's nothing coming back. So what do we need to do? In our .NET microservice, we implement a circuit breaker. So what this is doing is completely breaking any further requests between the .NET microservice and the third-party joke API. Again, another method to let this third-party joke API recover, but it's different, because the .NET microservice needs to have an awareness of its services calling and the state of it. So circuit breaker then, once it's invoked, you invoke it for a number of minutes. Up to you, arbitrary, depending on your requirements and how long you want to give it. And then for those X number of minutes, the circuit breaker will return a response, which will be a fallback. So our list of fallbacks or something that will keep your application running, even though the third-party joke API is not. And that, in essence, is the circuit breaker, so that every subsequent request that comes through from the client, if it's in the time window for the circuit breaker will be invoked, and it will return the response. So let's code that up. So the first thing I need to do is introduce a little bit of state into this controller. So I'm going to abstract this up to wrapping up to a field inside the controller. I'm defaulting everything. Apologies for my coding style. This is a demo. Sorry. And next I want to do is abstract all of the setting the policies. I want to abstract all of those into a method. And I want to move that method, which is called init policies. I want to move that method into the constructor. So it's a very, very rudimentary way of introducing state into this controller. But it proves the point. So you need state for circuit breaker. So in init policies, I then go and define the new circuit breaker policies. So I'm going to have to define 2 things here first. The first thing is the actual policy itself. It's imaginatively called circuit breaker. and it is a policy, and it handles. What does it handle? Do you see a pattern emerging here? So it again handles exception, and what does it do when the exception handles? It actually calls circuit breaker async. So the next stage is, how long do you want to invoke this circuit breaker for? So I'm saying if the third-party API gives me 5 exceptions, then invoke the circuit breaker for 1 minute. That's the policy. But I also need a fallback because the circuit breaker needs something to return. So I define a circuit breaker fallback. Again, this fallback is very similar to the general fallback, where I need an enumerable or a list of jokes to return. But for this presentation, it's going to be 1. Maybe when I do the presentation another time, I might actually think of a list of jokes. We've got time. Please give feedback. So the circuit breaker fallback needs to be invoked, and it's invoked when a broken circuit exception is called. So the broken circuit exception comes from the circuit breaker policy. So you see how Polly very, very nicely puts all this together. The fallback async calls an enumerable joke, or returns an enumerable joke, again, async function, with a single joke inside it, which will be the fallback. And another reason I like Polly is that the patterns that you program in just make sense and are elegant. So the new joke this time is similar. So it's got the 3 fields. It's got the setup, it's got the punchline, and it's got the source. Again, I'll leave the best bit to the end where I define the new joke. And then the source this time is going to be the circuit breaker fallback. So once I've defined the joke that the fallback is going to return, I then need to, of course, wrap it in my policy wrapper. So I set the order of precedence. So I've got my general and my retry. I'm actually going to put it in front between the policy and the retry policy. And so the first thing I need to do, I need to define the actual fallback. It's going to bubble up. But I need something to invoke the fallback, which is the policy. And then I'll put my other sync, my original policy, and then my retry. Sorry, my original policy. So that's my policy wrap. So think of it bottom to top order of precedence. So eventually I'll get my general fallback. So joke. Why did the developer go broke? Nope. Nope. No. Because they used up all their cash? No? Kaboom tish. Okay, so F5 that. Let's go. So let's refresh, and I think this time I actually invoked, I cheated for this one because this is a long time to actually invoke. So I'm going straight to the circuit breaker fallback because I've had 5 retries, the exceptions in the fallback is there. What I'm now demonstrating is a minute. It takes a minute. So I've defined this time as a minute. So every other request that I'm doing is going straight to the fallback. It's really quick, making the application responsive. It's not waiting for a timeout, not waiting for anything like that. It's just going straight to the circuit breaker, boom, straight back to the client. So it maintains a much more responsive feel than you would get if you were using a retry pattern. So a quick overview and a refresher. So think about it. Exceptions allowed before invoking. How many minutes the circuit breaker is in force. Again, up to you, arbitrary for the demo. Then once the circuit breaker is in force, return the fallback. So a minute's went past, and hopefully still going, still being responsive, still getting the fallback. Once I refresh it, There you go. How many programs can change a light bulb? None. It's a hardware problem. It's true. So now, the third-party joke API has come back. Our fallback is gone. And now we can start requesting the third-party joke API. It's returning. It may be slower, but it's returning inside the 5 exceptions that we've set for before the circuit breaker is invoked. Cool. So that's 5 patterns and more than 5 jokes. The next practice is the practice that I used for the third-party API. So it failed randomly, and I measured what happened, and I changed my application as a result. That's chaos engineering. Or, in other words, chaos engineering is the process of stressing the application by creating events, observing how the system responds, and implementing improvements. The key, you break it, you see what happens, you fix it. Chaos engineering, simple, that's it, bye. It's not. So chaos engineering implies chaos, it's not. There is a very defined process and phase of chaos engineering. I'll describe these to finish this talk off today. So you start in chaos engineering terms with a steady state. So a steady state is your application running, really happy, serving users, serving fantastic jokes, and then all of a sudden somebody says, "Oh, what about a hypothesis? What would happen if I stopped the third-party joke API randomly for a minute? Let's see what happens there." That's the hypothesis. When you've got the hypothesis, it's time to run the experiment. So I ran the experiment this is AWS Fault Injection Simulator. You don't have to use this. This is what I use. I work for AWS. It's nice to use. Other chaos engineering frameworks, Chaos, Simian Army, Chaos Monkey, whatever. But here I'm stopping my APIs. So my joke API is all in 5 EC2 instances. I'm setting up an action to actually stop them. So I call this action, obviously, stop instances, and I give it a really descriptive name, like will stop all API instances. Then I give it a type. So Fault Injection Simulator has a number of types that you can use. This one's called stop instances. And then after a minute, so I'm giving it a minute and saying once that minute is gone, I can start the instances again. The next thing I need to do is actually define the targets. So what EC2 instances or services or whatever that I want to stop. So I'm using tags to define those instances. And then I can define things like stop conditions if I want to. And it'll always give you a warning, because although it's called the Fault Injection Simulator, it will stop real things. You're warned. So here are my API servers that are running my third-party joke API. What I do now is run or start this experiment. Hit start, another warning, this is real stuff, not simulated. So that will start to initiate and eventually start running. So at the minute it's initiating, go back to my EC2s, they're still running. All good. Keep refreshing, they're still running. So I then have to jump back into my experiment and I refresh and you'll see now it's running. So I expect now my EC2s to come down. And there they are, so they're beginning to stop. And so what will happen now is those EC2s will stop for a minute and then start again. So once I've run that experiment, I then need to verify. So I need to see what's going on, what's happened. So I look at my observability, so my logs, what my application insights are doing, and I verify what's happened. So in my case, in this application, my joke application, I verified that things were taking longer than expected. I was getting timeout exceptions, things like that. I verified. And then once I verify, the next thing I need to do is improve. So what I'm showing now is after the minute, the EC2s would start running again, and the third-party joke API would start serving requests. So I can set this up on a schedule. I can set it up to run whenever unsuspecting individuals are running. Don't do that in production. No. You can actually, and if you're really high up the curve, you can actually run false injection simulators in production. Just be very careful about times. You don't want to run it at peak times. You don't want to run it when you've got an event on or anything like that. But they can be run in production. Most people run them in test. So now I've verified everything. I know what happens to my application. It breaks. So now I got to improve it. So how do we improve it? Well, we use the 5 patterns that we've defined, and that way we build a more resilient application. As well as EC2s, you can also run the fault injection simulator across ECSs, so you can drain containers in ECS, Elastic Container Service, or you can terminate node groups inside EKS, Elastic Kubernetes Service, and do other stuff like databases, reboots, failovers, which is very, very handy if your third-party joke API is actually a database. So there are the 5 patterns and 1 practice of KF engineering. I hope all of you found your bucket, either the ooh, or the oh yeah, or the oh. Thanks for listening. If you have any questions, please, you can either come talk to me, ask them now, reach out on Twitter, always available. Please come ask. I don't bite, even though nobody's sitting in the front row. And thank you very much. No questions. Come on. I've yet to see a question all day.
So we're going to start. Okay, so, yes, webcack. So today we're talking about the vulnerability that exists between the keyboard and the chair. Another name for it is, of course, social engineering. I don't know if anyone has seen the show Supernatural before. It goes on a bit forever. I've only seen the first half of it, but the first couple of seasons, it's basically all Sam and Dean social engineering their way into situations. They'll rock up at the door of some house wearing their suits, holding up their FBI badges, acting like they belong, and so the people will let them in and talk to them because they think they're feds. So they're just social engineering, they're impersonating, they're pretending to be something and convincing people that they're supposed to be there. So in the picture up there, Castiel's holding an FBI badge, and so the people they're talking to think that they're FBI agents. Can I get a show of hands? I'm pretty sure I know the answer to this question, but how many people here have seen me do a talk before or know me in person at all? I've got, what? 1. Fantastic. Okay. How many of you guys, and you probably can't read from the back, but how many of you looked at my badge? Because my badge says Stephen Carter. Well, the slide, where is it? Says Stephen Rees Carter, and the agenda says Stephen Rees Carter. My badge also doesn't say speaker. So you're all sitting there listening to some guy standing at the front of the room with the laptop and the clicker who is pretending to be a speaker, but my badge doesn't say I'm a speaker. In actual fact, I borrowed this one from someone whose name is very similar to me, thanks Steve, which makes for a fun demonstration. But the fact is, I'm standing up here pretending to be a speaker and you're all listening to me for the next hour. And you're unlikely to leave because it's rude to leave in the middle of a talk. And now that I've said that, you're really not going to leave. So have fun. If you do need to go, feel free to leave. I won't be offended, just want to get that out there. But the point is that social engineering is about tricking people and convincing people that you're supposed to be where you're supposed to be, or that you're supposed to be given the information that you're asking for, that sort of thing. Okay, so who am I? I am a PHP developer, which I feel very outnumbered in this place where there's so many .NET and other developers around, but PHP is awesome. Check it out. I love it. I am a security consultant, so I spend my time cleaning infected websites. No, what am I saying? That's an old job. I spend my time auditing code, reading people's code and looking for vulnerabilities, and then hacking into their sites in order to prove if there are vulnerabilities there or not, and to help them fix the vulnerabilities and keep their sites more secure. I write Laravel Security in Depth, which is a weekly newsletter about PHP and Laravel security. So go sign up for that if you do either of those things. And Laravel is a PHP framework for those who don't know. And I used to clean hacked WordPress websites. Doing well today, which is a fun job. If you're interested in security and malware and that sort of thing, then getting involved in cleaning hacked sites is quite an interesting challenge. So back to social engineering. The thing about social engineering is it doesn't have to be big and fancy. It can be incredibly simple. So here is, stayed at a hotel, and you've got back to your room, and room service are cleaning your room. What do? Well, I got back to my room one day in Vegas at DEF CON, which is the big hacker conference, and there's, 30,000 people in Vegas at the hacker conference. Most of them are hackers and social engineers, people that like to push boundaries, break rules, see what they can get away with. I got to my room, I loitered around the corridor while they were cleaning my room. When they were finished cleaning, they walked out, looked at me and said, "Oh, is this your room?" and held the door open. I walked straight into my room without the key. Kind of freaked me out a bit. I had to check my laptop, my passport. Wasn't that I didn't trust the cleaners, but the fact that they were just letting everyone into the room was a bit scary, especially since it's DEF CON and they let the staff know that hackers are in town doing that sort of thing. Another day, another hotel, my wife and kids were up in the room having dinner. I got back to the room late, I didn't have the key. I walked through the doors up to the counter and said, "Oh, sorry, I've forgotten my key." The lady behind the desk immediately said, "Which room number was it?" I told her the number, she wrote me the key, I walked into the room. Didn't ask my name, didn't look at my license. I didn't recognize her, she wasn't there when I checked in. I just looked trustworthy. I walked in the front door, for crying out loud, and she gave me the key to the room I wanted the key for. It's social engineering. It doesn't have to be fancy, it doesn't have to be big and flashy. If you look like you know what you're doing, people are going to believe that you're doing what you're supposed to be doing. Take, for example, these two. They rocked up at a zoo wearing these things. High-vis vest, $10 from Kmart. High-vis vest, they've got a clipboard, and they've got walkie-talkies, and they wandered around the zoo. Checked out all the exhibits. They also went to an amusement park, rode on all the rides. Again, didn't pay a single thing, because they looked like they knew what they were doing, they were wearing high-vis, they had radios, everyone just assumed they were where they were supposed to be at the time. Now, high-vis isn't going to get you into everything, and I'm not quite sure what these guys think they're doing. Are they trying to hide, trying to be seen? Who knows? Point is, social engineering. If you look like you know what you're doing, then people are going to ignore you. So, Twitter. A couple of years ago, Joe Biden tweeted this. "Giving back to the community, all Bitcoin sent to the address below will be sent back doubled. If you send 1,000, I will send back 2,000. Only doing this for 30 minutes. Bitcoin address." Kind of looks dodgy, but maybe it's a thing. Musk also tweeted the same sort of thing. The same message, I'm doubling the amount, Bitcoin address, etc. Now, granted, it is Musk. Who knows what's going on in his head? He might be legitimate from him, but it's the same address as the others, so it's a scam. Uber did the same thing as well, and a bunch of other accounts. So again, you've got the same thing, you've got the address, you've got the 30 minutes, you've also got the $10 million limit on there as well. And then a bunch of crypto exchanges also were included in this one as well. Gemini, Coinbase, Binance, and CoinDesk. So you've got a bunch of Twitter accounts, most of them are verified, and a lot of them have a lot of followers, millions of people can see them, all encouraging people to send Bitcoin to this address, and they'll get Bitcoins back. So it was a scam, obviously. These accounts have been compromised and taken over, and they're social engineering their followers into stealing Bitcoin. Now, I can't say a lot. Many Bitcoin owners, investors, whatever you want to call them, aren't tech literate, aren't security literate. They don't understand security and technology. They've figured out how to buy and sell Bitcoins and cryptocurrencies for many reasons, but they can't recognize a scam. And so they're going to see a tweet like this, and they're going to assume, great, this is great. I want more money. I have to pay bills, or I want this, or I want that. And they're going to send the cryptocurrency to it. Also, you'll notice here, we've got the 30 minutes there. So we're adding in urgency, which means that you see this tweet, you go, oh, great, there's only 30 minutes left. This screenshot was taken 8 minutes into it, so now there's 22 minutes left. I need to send my money quickly. Likewise, we've got the $10 million limit up here, which means that you see this, you think, oh great, I really need to send my money quickly, otherwise it's going to run out and I'm not going to get my Bitcoin, my double Bitcoin. So there's social engineering in here. You've got the scarcity, you've got the urgency, and you've got the recognizability of the account that's posting it. The Uber blue tick there, this example, is social engineering their followers who have cryptocurrency to send their money in order to make more money. That's the theory, that's the hook, that's what they want. In actual fact, this scam didn't really make them very much money. Granted, it's 13 Bitcoin, you've got, some $260,000 at the moment in current money. But from what I've read, apparently this was a very small payoff in terms of crypto scams. I don't know too much about crypto, so I can't really talk about that. But the point is that it didn't seem to gather as much as they hoped it would gather, which is interesting in itself. So what happened is Twitter themselves were hit with a social engineering attack. So what Twitter said in their press release was that the social engineering attack occurred on the 15th of July 2020, and it was a phone spear phishing attack. Right, so what that means is it was over the phone. So someone called up, like the support helped, and a spear phishing attack is targeted. So it's not just a scatter phishing attack where you just send like emails out to everyone, but you gather your information and your research first. So it's the difference between calling up and going, oh yeah, hi, I work there and I forgot my password. Can you give me the password? They're going to hang up on you and call security. But if you do your research and figure out the name of the tools you want to access, the name of their manager, other people that work there, and you could call up and go, hi, my name's Mark. I'm currently on site with a customer. We've got a big launch that's going on. My logins aren't working. I can't get to tool name blah. My manager Bruce and your manager Bob are good friends and they owe each other favors. Can you just help me out here? The person you're talking to is going to want to help you because you've laid the groundwork and they do sound believable. You're helping a customer and they've got a big launch, so there's the urgency there. And there's the favor in terms of the managers. So the person you're talking to wants to keep their manager happy. Maybe they're going for a promotion or something. And when they hear that their manager is going to hear that they're helping you solve the problem, they're more likely to help you. And so they'd hand over the credentials. Now the interesting bit was, not everyone they targeted in their initial attack had the access they wanted. But they just gathered more information in the first attack and then they tried it again. And their additional targets here was what they needed to get the credentials of the employees. So once they had the credentials for the internal tools, then they were able to log into the accounts, take them over, post the tweets, follow through with the attack. Now I love this line in the press release where Twitter say here, my screen's really easier, the attack relied on a significant and concerted attempt to mislead certain employees and exploit human vulnerabilities. So exploit human vulnerabilities, that's social engineering. That's the problem existing between the chair and the keyboard, or those chairs and the screen up here. I'm exploiting in the scenario we had with the badge at the start. So it's all about exploiting the human, the person that's vulnerable, and finding that weakness, rather than looking at some technical vulnerability like SQL injection or whatever. So how do we solve the problem? And it's a tricky one because it's a people problem. It's not simply a case of write more code, add more filters in place. And it comes down to security awareness training and building security into systems. And so teaching your staff to recognize phishing attacks, teaching them to recognize what a dodgy phone call sounds like and who should have access to things, but also maybe adding controls in place so that the high-profile accounts like Musk and Uber and such cannot be accessed by the normal staff. Maybe you need multiple staff members to approve things. And that way, if you're doing an attack on them, you need to convince multiple staff members, not just one staff member. But that comes down to your tooling and your systems, and you've got to build them in such a way that makes sense for your environment, what the access is needed. And it's a tricky problem to solve because it's the people problem, it's a human problem. So on the subject of cryptocurrency, one way to steal it, of course, is the technical avenue. You could try break into, say, Coinbase or something, but I guarantee they spend a lot of money and time on security, so good luck trying to break into there. The better option, again, is to go after the human. So here we've got a pretty standard interaction on Twitter. This person here, Murky Waters, is posting about a problem they're having accessing Coinbase. Coinbase, being a nice corporate citizen, is responding and saying, reach out to us, we'll help, blah, 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 the usual. But that wasn't the only response they got. They also got this person up here going, here, talk to this person on Instagram. They can help you out. I bet you know what's going to happen with that one. There's also this response as well. This is all on the same tweet, by the way. This person came in. We have another person on Instagram who can help. The username here is quite interesting, hackkey360. What's that suggesting? And I'm encouraging you to not bother with Coinbase support, saying Coinbase support are useless. Got another different person on Instagram here, and another one. So this one tweet has those 4 people going, talk to these people on Instagram to get their help. And as I said before, the cryptocurrency people aren't always tech literate and security literate. So they're going to see this and think, oh, this person can help me. I might reach out to them. I'm assuming that they're going to Instagram off Twitter to make it harder to trace and to track and to shut down. We've also got this one, which I love, where Coinbase Helpline responds and says, send us a DM and we'll help. They're impersonating the real Coinbase support, obviously. They realized here that they've CC'd in the official Coinbase account, so they do a second tweet, which is identical, but they're missing the CCs. They just forgot to delete the first one, so that's pretty funny. And then to add some more, we've got some more support, Coinbase support, so Coinbase Help 22 here, and here, this bottom one, Coinbase official support, all in caps, because, I don't know, it's official. And I love this last line. This is brilliant. Beware of impersonators posing as support. We'll never DM first. It's like, yeah, let's ignore the fact that they're an impersonator. But I'm guessing Murky Waters has probably got a whole pile of DMs from people claiming to help with this as well. These are just the ones we can see that are public. So, attacking the human vulnerability there, the person that needs help and doesn't know any better on Twitter. Now, if you want to go after the big crypto investors, you've got to follow the 5-step plan. And just a disclaimer, I don't do crypto. I've never done this. I don't know if it works. This is based entirely off what I've read and learned. I've never done it. The big disclaimer, if you do it yourself, it's not my fault, right? Just want to get that out there in case someone, yeah, anyway. The 5-step plan. First up, we need a data breach. We need to figure out who crypto investors are. Luckily, we have Ledger. Ledger is a hardware crypto wallet manufacturer that had a data breach 2 years ago. The data breach included email addresses, names, phone numbers, physical addresses, which means we have a list of email addresses of people that we know have cryptocurrency in some form. We can then look for those accounts on exchanges like Coinbase and such. We can match up those email addresses from the Ledger data breach with credential stuffing lists from other data breaches to find valid passwords that they've used elsewhere. And then we try to log into Coinbase or the other exchanges to see if the password and the email let us in. In the case of Coinbase, if they let us in, we're going to see something like this. On the left, we have our SMS two-factor auth screen. On the right, we've got the Authenticator app, and you might also get like a hardware authentication as well. If you get anything but the SMS two-factor auth, there's no point trying with that because you've got to physically get access to their device or things like that. But if we're looking at the SMS two-factor auth, we've got the last 2 digits here. Do you remember what Ledger included? Phone numbers. So you match up the phone number in the Ledger data breach with the last 2 digits here, and that tells you the phone number of the account you're trying to break into. Then it's just a simple matter of doing a SIM swap, which is not simple, but it's doable. You could just, one method would be to call up the carrier and try and convince them that you're the account holder. You've got their name, you've got their address, you've got their phone number, you've got their email address, you've got a password for them. You could probably find them up on Facebook. There's a good chance you'll find their birthday because people post about their birthday and they post about their age. So you've got their date of birth. You might find the pictures of their pets. They're usually security question answers. So you get all the information. You can probably do a SIM swap on their account by convincing the phone carrier that you're the person they think they're speaking to. Apparently a different method they're using for this is you actually social engineer the credentials for the manager tablet of the people that run the phone stores. You run into the store, steal the tablet out of their hand, run out, and in the 5 to 10 minutes it takes them to deactivate the device, you physically do the SIM swap yourself on their devices in the management console with the credentials that you stole from them. And the payoffs for these are hundreds of thousands of dollars, if not millions of dollars in cryptocurrency. And so you're going to go through the risk of running into the store to steal the tablet and setting all that scenario up in order to make the money because there's a large payoff. Of course, it's crypto. The payoff involves getting the crypto somewhere else which can be tracked and then getting it out somehow. I don't know. I'm not a crypto person. All I know is it's really tricky to actually do anything with crypto that you steal if it's large enough quantities and it gets reported quickly. So figure that one out on your own. I can't help you with that one. Sorry. It's not part of the talk. So, again, fixing this problem, solving this problem, user education. It would be really fascinating to see if Coinbase and a bunch of and all the other exchanges ran their crypto users through mandatory security awareness training every month. How many scams would fail because people are actually aware of phishing attacks and are thinking about it. Granted, the users are going to get sick of it because who wants to do security awareness training every single month and they're going to find someone else that doesn't do it and then they're not going to learn security. So it's a hard problem. That's why exploiting the human vulnerability is so easy. All right, this guy. This isn't crypto related, yay. This guy here, Lithuanian man, I can't pronounce his name, I'm sorry, it's just down here. So he convinced Facebook and Google to send him more than $120 million by selling them a couple of bills. So what they did was they called up Facebook and Google and spoke to them many times to gather as much information as they could. They did a bunch of recon. They sent them phishing emails as well in order to obtain a lot of information. They spent 2 years gathering all that research so they could make a phone call to these companies saying, can you please pay our bill? And the Facebook and Google said, yeah, sure, we'll pay the bill right now. And they did. They stole $120 million because they asked nicely after doing a bunch of research. Again, all social engineering. What's the point in hacking when you can just call up and ask? So I got this email about a month ago. As a side note, the name up there is, I'm guessing, because my name used to be Stephen Rees before I got married, and I'm guessing this guy actually has my name wrong in his address book. But I know this guy, I haven't seen him in about 10, 15 years. And so what I'm guessing happened here is that his email account has been hacked and the hackers have sent these emails out to everyone on his address book, hence the wrong name. But this guy is tech illiterate. He has no idea about computers, which means that email looks real. It looks like the sort of thing he'd send me. There's no context whatsoever. It's just a link to Google. So, you know, what's wrong with it? But it raises alarm bells anyway because I haven't spoken to the guy in, 10, 15 years. And if you hover over the link, you'll see that thing, as opposed to the Google account that's down there. So yeah, so you see that thing when you hover over it. So that's the sort of thing you got to look for. It's hard to show the hover on the screen. That sort of thing you got to look for when you receive weird emails is, you know, where it's actually going. Of course, it's hard when you get mailing list things and they've got tracker URLs that go to big long things anyway. But yeah. So, got this email from the guy. Check out this one. So figured I'd have a look where it's going. As you can see, it bounces through a couple of places. Before we get here, which is, what was the first thing that you all noticed? Just shout it out.
It's not HTTPS.
Really? That's the first thing you noticed? It's actually HTTPS. It's got the cross through because it's Burp Suite. The thing that I noticed, apparently you're all better at this than me. Yeah, I noticed the ABC News bit. And so this page is pretending to be ABC News. Granted, the domain name makes no sense whatsoever for ABC News. The HTTPS is irrelevant in this situation because of how I loaded the page, because I was running it through my tracker thing. But the point is they're trying to be ABC News. But they've got this super clickbaity title. ABC News is not going to do that. And the whole featured in thing, you're not going to see it on ABC News. So they've completely missed the point on this page. But it's trying to be ABC News. It's trying to be a legitimate page that an Australian would see and believe. If you scroll down, you're going to see photos of celebrities and fake quotes, and then a payment box at the bottom for supplements, so you can go buy their weight loss supplements. I threw it on a UK VPN, got that thing. A little bit more believable from what I've heard about Mail Online. You might actually see this sort of stuff on there. Again, the domain name is complete rubbish. But most people don't look at that anyway, but you're going to see Mail Online, the female section, you're going to see the headline, blah, blah, blah. You might actually believe this and fall for it. Now, keep in mind, this all came from, where'd it go? That Google domain. So if you actually remember what you clicked on, it makes no sense whatsoever. But what they're trying to do here is trick you into buying the product, handing over your credit card details by impersonating a site that you might believe and trust. So they're building that trust in there, setting up that scenario. Okay, so anyone here know about PR Guy 17? Seeing a few reactions, cool. So PR Guy 17, for those who don't know, is a Twitter account, a left-wing, pro-Labor commentator, I should say, who popped up during the lockdowns and pandemic down here in Victoria. And the right-wing media and right-wing commentators are pretty upset by PR Guy 17 because he's anonymous and they don't know who he is and he's being annoying them because he has such good takes. The point is they're trying to unmask him, and so they've done various legal things to try and get information, and Twitter handed over an email address and IP addresses for PR Guy 17. And they said, the person running the thing, this Avi Yemi, can't pronounce his name again, sorry, he said that he's given those details to a cybersecurity expert. A couple of days later, PR Guy 17 receives this email. So it's all very interesting. We check the subject at the top, and you've got strictly confidential, PR Guy 17, letter of demand and confidentiality agreement, reference number. So it's trying to make it look really, really official and legal and encourage him to open the link. And you've got strictly confidential again, a lot of legal jargon. You've got the URL and the password, the legal details about the law firm, the attachment at the bottom. It's trying very, very hard to get this guy to open up the docx file. But he didn't click it, which is a good thing, because you can imagine what's in there. The other thing to remember is because there's a password on the document, virus scanners can't read it. So you've got malicious scripts, macros, anything else running in the docx, the virus scanners can't pick it up. Because if virus scanners could read the unencrypted version of the file, what's the point in the password? So that's how you slip viruses and malware through virus scanners in doc files. And they're trying to socially engineer PR Guy 17 into opening that, presumably to hack his computer because they're having no luck figuring out who he is. It's all pretty obvious who it came from. The timing is pretty clear. The fact it's all themed around a legal thing is pretty clear. Also, the fact that the only people that have that email address are Twitter and the people trying to figure out who they are. So he's used a burner email address. So, again, it's a pretty blatant phishing attempt. Pretty interesting though. I'm very curious to see where it goes. Because I know some of the news sites, media are trying to figure out, what the lawyer is they could be referring to because none of the lawyer details actually make sense, like the phone number doesn't work, etc. So anyway, okay, on to a different phishing scam. You can probably guess this one's crypto, given the amount of money. I just thought this one was quite fascinating. So this person received multiple notifications on their Apple device about failed logins and failed pins and that sort of thing. So a bunch of different security alerts. So they were on security alert, they were worried about the security of their device. Then they received a call from who they thought was Apple. The phone said it was Apple, so they thought it was Apple. And the Apple called them and said, we're trying to secure your device. We're going to send you a one-time PIN, give us the PIN. So they thought they were talking to Apple. They handed over the PIN, which allowed the hackers to drain their crypto wallet, all from giving over the PIN on the Apple device. So what's going on here is the crypto wallet they use on the phone backs up its keys to the iCloud, which means that all the hackers have to do is get access to the iCloud backup, then they can get into the crypto account in order to steal the coin. And so it's quite fascinating. So that's just some more details this person put up about it. But it's fascinating they laid the scene. So the attackers targeting this person sent through the security warnings. And they set out that scenario so the person is thinking about security, so that when they called up to talk about security from Apple, the person was believing that they were talking about, that there was something important going on, that they had to pay attention, that it was really Apple, because they thought there was a security risk, which there was, but they didn't realize they were talking to the hackers, not Apple themselves. All right. Physical security. Phone skimmers. No, not phone skimmers, card skimmers. What am I saying? This one's pretty obvious. If you're looking at a side-by-side photo, the one on the left, of course, is the skimmer. The one on the right isn't. But if you didn't have the one on the right, are you going to notice that thing sticking out? You don't know what these devices look like. Every single ATM and card reader is different. So how do you know what is the skimmer and what isn't? It's only by looking at a comparison like that, someone pointing it out, that you realize that it shouldn't be there. Oh, what's the next one? Where's the skimmer here? I heard someone say it before. Yellow thing, yeah. Yeah, the yellow thing up here is the skimmer. It probably, that's where the card goes in anyway. But it's slightly hard to see, but the yellow thing actually goes over the arrow. And if they were designing this thing properly, the arrows would be below it, not under the yellow thing. And so if you know what you're looking for, that one's obvious. But you're not really going to pay much attention. And it's recessed in rather than sticking out, so it's a lot harder to see as well. So what about these things? Have you seen these things before? See the faceplate? So the skimmer here on the right hops over the one on the left. It looks basically identical. It's just slightly thicker and fatter. You're not really going to notice the difference unless you have good working knowledge of these things and know what to expect on them. So again, So that's a tricky one to find. I think also because it covers the entire device as well. The usual wiggle trick might not reveal it as much. And of course, this next skimmer, have fun finding this one. It's a really hard one. Yeah, thought that was funny. Okay, so not really social engineering, but kind of, I don't know, I thought it was interesting. This one, this person has a photo of possibly their keys. I hope it's not their keys. Talking about their address and what time they normally get home during the day, which means that if you want to break into their house at this address, go before 5 p.m. And if that's their keys and you know how to pick locks or make your own keys, then you've got the keys to get into the house. Even if you don't, you probably could pick it anyway. And they've told you they've got a safe. So what's in the safe? You know, if you're interested, they might have something valuable. Break into the house with plenty of time to pick into the safe. Go for it. So yeah, I guess it's the human vulnerability in terms of the information they're leaking about their house and when they're home. Okay, so I've got a video here of, is it going to play? No, cool. Video here of phishing, which is phone phishing. I thought it was fascinating to watch.
They're going to hack me using social engineering, which is essentially hacking without any code. They just use a phone and an internet connection.
Do you want to do a sample phishing call?
What's phishing?
Phishing is voice elicitation, and basically what you do is you use the phone to extract information or data points that can be used in a later attack.
Let's do it. Who are you going to call?
Maybe I'll call your cell phone provider and see if I can get them to give me your email address.
I bet they're good. I bet they have my back. But yeah, go for it.
I'm going to spoof from your number, so it's going to look like it's calling from you.
Okay.
Hi, I'm so sorry. Can you hear me okay? My baby, I'm sorry. my husband's like, we're about to apply for a loan and we just had a baby and he's like, get this done by today. So I'm so sorry. I can't call you back. I'm trying to log into our account for uses information and I can't remember what email address we used to log the account. The baby's crying and can you help me? Awesome.
In just 30 seconds,
At gmail.com?
Jessica gets access to my personal email address.
Now, if I needed to add our older daughter on our account so she could call in and make changes, how would I need to go about doing that? You would have to send me a secure PIN through a text message? Yeah, well, the thing is, I don't think I'll be able to receive a text message if I'm on the phone. Oh, I'm not on there either? So I thought when we got married, he added me to the account.
Jess uses my girlfriend's name and a fake social security number
5127.
to set up her own personal access to my account.
Wait, I'm sorry, so there's no password on my account right now? Can I set that up?
She even gets the support person to change my password.
Thank you so much for your help today.
So she just basically blocked me out of my own account.
I'll get her fed after this. All right, thank you.
There we go. It's that simple, apparently. All you need is a baby. All you need is a baby crying. Yeah. So she set up the scenario with the baby crying and the urgency, telling the rep that she had to do it then, she can't call back later. So the rep is conditioned to want to help her. And then when we get to the part where, you know, she discovers she's not on the account, the rep is trying to be helpful and doesn't want her to go and talk to her husband and get permission and all that rubbish. So she just does it for her to be helpful because she believes she's trustworthy. So yeah, it's fascinating. So I've got one more video. This one's fun. I'll just preface it. So we had APEC here, whenever it was, in Sydney. I think it was Sydney, a little while ago. And the Chaser team decided to see how good the security was. Because that's what they do. Oh, there we go. Please work.
Oh, he does. Look, $160 million they spent on APEC security, the biggest lockdown operation the country's ever seen, and yet there were holes in the security wide enough to drive 3 trucks, 2 motorcycles and 4 Secret Service guards through.
Top effort, blokes. Let's have a look now at how it all unfolded. Talk us through it.
Okay, well, Osama likes to travel in style, right? So we made a do-it-yourself motorcade, cunningly disguised with this Canadian flag.
Oh, yeah. It's a modern-day Trojan horse.
Yeah, but there are a few hints we were fakes, like our official code, SFA. Yeah, I don't think motorcades have had runners since JFK, especially not ones with handy cam.
But once we were rolling, nothing was going to stop us, except...
Fuck, we got a red light.
let him through.
But yeah, the cops don't keep us arm away. So watch this guy here. He stops the traffic and then waves us through.
That was amazing. No questions asked at all. On we roll. Right up to what they call the ring of steel. There it is. And didn't security jump on us? We stopping?
No, you're fine.
Yeah, not too much checking at that checkpoint.
Yeah, so look, we were just walking on down, right on down to the red zone. Now that is the real no-go zone. But I tell you what, it's pretty relaxed in there.
Look at this guy come up here with his back to us. I don't know what he's looking at.
Yeah. Now, you know, the media said we got past a second checkpoint, but it wasn't really like a checkpoint. It was more like a guard of honour.
Not too fast, are they?
Yeah, now look, by this stage, it's become pretty bloody obvious the cops weren't going to stop us, so we decided to stop ourselves.
Sorry.
I'm sorry, I'm going to have to turn this around. We've got to go back. Okay. Now, at this stage, we've got much further than we ever expected. I think that's fair to say. And all of a sudden, we're trying to turn around a motorcade right in front of George W. Bush's hotel. Chaz, I was a bit worried.
Yeah. But as for the cops, well, they weren't so worried.
It's around a bit. We'll just go back this way, okay? Okay, turn around. Thank you very much. Thank you, officers. Good work. Great work. Well, they did say the road was ours.
Ours to do whatever we like, apparently. So, look, we've been in that car for ages, so we thought we might stretch our legs a little.
Okay, let's walk. Yeah, all right, let's go. He's walking with me. All right, come on, let's go. And I think this is when they got a bit suspicious.
I think so, yeah.
Who are you? Officer Julian Morrow. VIP liaison. Okay.
So here I am, Osama bin Laden, staying 10 metres away from Bush's hotel. So what do? They arrest the other guy.
Oh, no, hang on.
Oh, there's some other guys coming to arrest you now.
No, they're for me as well.
Poor old Osama.
Yep. What can you say to that? So, you know, the cops weren't looking for a fake motorcade. The cops obviously figured someone else was validating and, you know, checking what was coming in, and so they just let them through because they looked like they were in the right place, in the right part. They weren't paying any attention to it. Again, social engineering. Being in the right place, being somewhere where everyone thinks you're in the right place, I should say, and convincing them that you're supposed to be there so they don't pay any attention to you whatsoever. All right, so I want to finish on this one, and this is why a lot of people hate security people. There's a lot of big companies and places will do like fake phishing tests to see who's paying attention and then throw those people who fail them through, you know, security awareness training. But doing one of these tests where you've got a financial incentive, like, you know, $7,500 for the people that are struggling with money and bills, is unethical. It's mean. And the people aren't going to learn anything from that. I mean, this person isn't going to learn about security awareness and phishing, detecting phishing from this experience. They're going to hate the security team. And they're going to hate the whole security process around it and the fact they have to sit through boring security awareness training. And so, yes, granted, that's the sort of thing that a phisher would do. If you were doing a legitimate attack to get this person, you would, of course, send that email. But if it's part of your security training and awareness, it's not a good idea. It's unethical. It's just going to leave a bad taste in everyone's mouth, and they're not going to learn anything. So you need to go about security training in a different way, a way that actually educates and teaches people. And that's actually it. Apparently I've finished really, really early for some reason. I must talk fast. Thank you for coming. Are there any questions or anything? Cool. Oh, question? Yep. I think there's a microphone. Probably goes on the recording if you use that one.
Email has been compromised and it's in one of those leaks and they've got it, as well as your phone number and your address and your date of birth. And then you get, you know, these phone calls and, you know, from unknown numbers. You know, so eventually what I did was I kind of, you know, made that email address an alias, you know, which then gets put into the junk straight away and started using another email. But I turned on silence unknown callers, which is problematic when I actually want to receive a phone call from an unknown caller. What can I do, if anything? Have I done the right thing?
Well, out of all the things you listed, the only one you can't change is your date of birth. So yeah, changing your email address, changing your phone number, if it starts getting targeted. Yeah, I mean, there's not much else you can do apart from just be aware of potential scams and, anything that comes in, look at it and think, is this a scam or is this legitimate? Yeah. In terms of keeping like your account secure, that's where having different passwords comes in. And it's recommended for things like crypto and such that you actually use different email addresses for your accounts, so that if you've got your account breached over here, well then it's not the same email address that you're using on the side here. Even though you've got different passwords, having a different email address as well makes it even harder for someone to try and target your account.
So I've certainly started using Hide My Email.
Yep.
So whenever I go out to a pub or anything like that, I'm always going to be using that. Even when I'm doing online shopping, same sort of thing.
Yeah.
So it just seems to be a fair bit of effort, so that when I wake up in the morning, I don't have 37 phone calls and 150 spam emails.
Yeah. Yeah, it is definitely a bit of effort, yeah.
All right, thank you.
That's okay. Yeah, I guess that's the problem with this sort of thing, is that once the information's out there, you can't do much about it, except for manage it or change the details you can change, and just accept the fact that anything that goes to the old email is potentially compromised. Yeah, it's a tricky problem. That's why it's still such a big thing. Cool. Any other questions? Yep, go for it.
Well, I've got the expert in the room. Not only for myself, but say for my kids and wife. When we get these phone calls from people we don't know, how should we answer them? Because at the moment on my voicemail it says, "Hello, you're speaking to Michael Jones, please leave a message." Other people, you just don't get anything, which I think is a bit rude, but maybe that's what you need to do. Can you give us some pointers, please?
I don't know. I mean, I guess that's, I don't know. I honestly don't know. It is a tricky one. If you want people to be able to call your number and know that they've reached you, then you've got to put your name in it. And then it just, I guess, you just don't trust the phone call. And what's quite common, and what a lot of businesses are actually waking up to, is when they call people for reasons where you say to them, is there a number I can call you back? And so you physically call back the company based on the information you find on their website, rather than talking to them on an inbound call. And so then inbound calls you basically screen and don't provide any information over those. Because you sometimes get the companies that want to verify who you are when they've called you, which is just complete rubbish, and they get upset with you, that one. But it's a tricky problem, and you can try you can change your phone number and such, but then if the new one gets out, then you've still got the same issue. Yeah.
What I've done with those type of marketing calls on the Bingham call register.
Yeah. Yeah.
I normally give the company 3 warnings.
Yeah.
Please take me off your list. If you call me that a third time, what I would do is I'll go through a fake order or a fake consultation. Send something out because you don't have my right address.
Yeah.
So that happens a couple of times to the whole company.
Yeah.
I actually got a phone call from the owner of the solar company after they came out and said, "Oh, what happened?" The call centre said they'd spoken to you. And I said, "Yeah," gave them 3 opportunities, and I went through the big.
Yeah. Yeah.
I still get marketing.
Yeah. Yeah, exactly. You can't really stop them. And they're always very cagey about where they got your phone number from. Yeah. Yep.
So I usually, whenever I'm just getting called, I go to the whole, please give me the invoice number, ticket number, or whatever department.
Yep.
Is there some way of flow that they can take me on to actually still get information from me by doing that? Or like, is there some sort of way of going from that to actually searching any details out of something?
Sorry, so when they call you, they're trying to get details out of you.
Yeah, so like, what is it to be aware of? Usually they just hang up and ask me the voice message.
Yeah.
Could they just kind of keep talking?
Yeah, yeah, probably, if they can convince you that they're who they're claiming to be, yeah. I think in those situations, you'd probably just want to get their number and say, I'll call you back, and then call them, rather than keep the incoming call going on. Yeah.
This don't use the phone numbers they provide you.
Oh, yes. Yes.
I was looking for like that,
Well, yeah. I mean, if they can convince you to go to a fake company website that has a fake phone number, and it's quite an extensive attack. But if they're specifically targeting you or they've set up the stuff, then yeah, they could do it. Yeah. It's a tricky problem. Yeah.
Can you speak at all on the deliberately making things look like a scam to filter out people who are likely to notice the scam?
Yeah, it's I guess it's the low-hanging fruit scenario. If you make it look like a scam, then those who know how to detect scams don't respond to it. Then you have to deal with less people that are going to figure out that it's a scam the further they get through. Is the theory that I've heard. Especially like the email ones where they're wanting to get your bank details or whatever to transfer money around countries and all that nonsense. And yeah, so if they make it so that only those who respond are actually likely to believe it, then they have to put less effort in because there's a manual process involved in it. Yeah. Cool. Oh, thank you all.